In this video, I'm going to discuss the concept of airspeed versus ground speed. First thing I need to do is define what is airspeed and what is ground speed. Well, airspeed is just the speed of an aircraft relative to the air that it's flying through. Ground speed is going to consist of the airspeed, but then also needs to take into account the wind speed. So in this simple example, you can see that you have wind speed that's going in the same direction as the airspeed. In this case, it would be a tailwind. So if you wanted to get the ground speed in this example, then you would just add the wind speed to the airspeed. If you flip that wind speed arrow around to where it becomes a true headwind and it's going directly at the plane, if you wanted to get the ground speed, then in that case you would then subtract the wind speed from the airspeed. But what happens if the math isn't quite that simple, right? If it's not a true headwind or a true tailwind and you've got to do some trigonometry. I like this example because it goes through this resolving of, in this case it's a resolving of velocities, but you can also do the resolving of forces, just like what you have to do in physics. So I pulled this problem out of an old textbook, and in this problem it says that an airplane is heading north 30 degrees east with an airspeed of 550 miles per hour, and the wind's blowing at north 155 degrees east at a speed of 50 miles per hour. And they want you to solve a couple of things. They want you to solve ground speed, drift angle, and the course of the jet. So let's start with the airspeed. Let's start with this heading of north 30 degrees east. So in this case, we're going to start at due north, or in this case, it's going to be in the positive y direction. And we're going to rotate clockwise, or in an easterly direction, by 30 degrees. So that means that we're 30 degrees from the positive y-axis, and that we're 60 degrees from the positive x-axis. Remember that the magnitude is 550 miles per hour. So in this case, we want to get the x component of this airspeed and also the y component of the airspeed. And to do that, we want to take the magnitude of the airspeed and then multiply it times the cosine of the angle between the direction of the airspeed and then the direction that we're interested in. So in the x direction, it's going to be 550 times the cosine of 60 degrees, or 275 miles per hour. In the y direction, it's going to be 550 times the cosine of 30 degrees, which is going to be equal to 476.3 miles per hour. Now we need to take into account the wind speed. So that's north 155 degrees east. So again, we're going to start north, and if you go all the way over to the x-axis, that's going to be 90 degrees, but we have to go below the positive x-axis by another 65 degrees. So you can see we're 65 degrees below the positive x-axis, which means that we're 25 degrees from the negative y-axis. And we have a magnitude of 50 miles per hour. So just as we did before, we take the magnitude of the wind and multiply it times the cosine of the angle between the direction of the wind and the direction that we're interested in. So that gives us wind speed in the negative y direction of 50 times the cosine of 25 degrees, of 45.3 miles per hour. And it gives us wind speed of 50 times the cosine of 65 degrees in the positive x direction, or 21.1 miles per hour. So here's the summary of what it is that we computed. So we have the components of airspeed and the components of wind speed, and now we need to sum up the x components and the y components in order to get our ground speed. Okay, so our x component, now remember both x components are in the positive x direction, so that's 275 plus 21.1, which is going to give us 296.1 miles per hour. In the y direction, we have one positive, one negative, so we have 476.3 miles per hour minus 45.3, which is going to give us 431 miles per hour. What we want to do is now want to find the resultant speed. Since this is a right triangle, we're just going to use the Pythagorean theorem and say the ground speed squared is equal to 431 squared plus 296.1 squared. Then we solve for that and get a ground speed of 522.9 miles per hour. If you recall, the airspeed was 550 miles per hour. Now we want to determine the course of the jet, and we do that through trigonometry. So remember, we have 431 miles per hour in the y component, 296.1 in the x component. So we want to know what is the angle from the positive x direction. So we'll call that x, and we just know from trigonometry that the tangent of an angle is equal to the opposite divided by the adjacent. So it's going to be 431 divided by 296.1. We take the arctangent of both sides, and we get that it's 55.5 degrees. Now we're all going to want to know what it is from the positive y direction. Of course, we know that the sum of that's going to be 90 degrees, which leaves us with 34.5 degrees from the positive y direction. So when we want a heading, or if we want to convert that to a heading, we know that that's north 34.5 degrees east. So now we've solved for the ground speed, solved for the course of the jet, and that leaves us with just the drift angle. So if you recall, the north 34.5 degrees east was the ground speed direction. Our airspeed direction was north 30 degrees east, so it's just the angle between those two is the drift angle, or the effect of the wind. And we know that the difference between those two is 4.5 degrees. I hope you found this video helpful. Remember, this technique can be applied to not only these velocities, but to forces in physics also. Thanks for watching this one.